The second part of quantitative data analysis is more about to achieve the research objective on exploring the relationship or determine the factors that influence or cause the changes in the dependent variable. Okay, so the analysis are categorized into three. Okay, relationship between variables, regression analysis, and the association between two categorical variables. Okay, for the correlation analysis measure the strength and direction of the linear relationship between two variables. The value of correlation is between -1 and 1. Correlation does not indicate cause and effect. Positive correlation means two variables are moving in the same direction, and vice versa for negative correlation. If data normally distributed, we use Pearson's method, or else you can use Spearman's method. Okay, so this is the guideline to interpret the correlation coefficient value. Okay, if the value of R greater than 0.7 or R less than -0.7 indicate it is a strong relationship. If R between 0.4 and 0.69 or R between -0.69 and 0.4, it is a moderate relationship. If R less than 0.4 or R greater than -0.4, it is an indication of low relationship. Okay, so for demonstration, so let's say we refer to the online shopping habits data. Okay, so perform correlation analysis to determine whether is there any relationship between factors convenience, informative, time, cost, and security. Okay, so use both method, okay, Pearson and Spearman, and let's see what is the difference. Okay, so go to the online shopping data, go to analyze, okay, and then choose correlate, okay, and then choose bivariate. The variables adalah convenience, okay, informative, time, cost, okay, and security. Okay, so the correlation coefficient is either to use the Pearson if the data normally distributed. If the data not normally distributed, kita pakai Spearman lah. Okay, so tick Spearman and then click OK. Okay, so there are two output of the correlation. The first one is the Pearson. So dia akan tulis dekat sini lah, Pearson correlation. Okay, if the correlation is significant, dia akan letak star dekat sini. Okay, one star indicate that correlation is significant at 0.05. Okay, so actually I have already make a summary here. Okay, based on the Pearson correlation, actually there's only one pair of variable that has a significant relationship, okay, that is significant at 0.05%, okay, which is the convenience and security. Okay, while the rest, okay, security and cost, convenience and cost, and convenience and informative. Okay, so these three pair of variables are significant but at alpha 0.1. Okay, and the rest, okay, all of them are not significant. Okay, but if I use Spearman raw, okay, for Spearman raw, there are two pairs of variable are highly significant, okay, cost and security, and convenience and informative, and then they are significant at 0.05. Okay, so I put a yellow color. Okay, and then for security and convenience, okay, the correlation using a Spearman indicate that security and convenience, the relationship is significant but at 0.1. Okay, So how to interpret? Okay, there were significant relationships, okay, between cost and security, convenience and informative, convenience and cost. Okay, significant at 0.1. Convenience and security, they are significant, okay, at 0.05. Okay, for spearmint, okay, but please make sure that the data is you make sure that you test the normality of the data. Okay, if the data is normal, then you can use Pearson. If the data not normally distributed, use spearmint. Okay, for spearmint, okay, this is the interpretation. Okay, and then you can support, okay, the analysis by using the scatter plot. Okay, scatter plot also indicate the strength and the direction. Okay, low relationship if the scatter plot, okay, the points are widely scattered. High relationship if the points are less scattered. Okay, so to plot the scatter plot via SPSS, so I will choose the variable of convenience and security. Okay, so I just go to graph, okay, legacy dialog, and then choose scatter / dot. Okay, put a simple scatter plot. Okay, so the y-axis, okay, let's, okay, here y-axis is the convenience, the x-axis is the security. Okay, convenience and the security, the x-axis, and then just click OK. Okay, so this is the scatter plot, the convenience versus the security. As you can see that it seems like there is a positive relationship between the convenience and the security. Okay, based on the coefficient also, okay, you should get a positive value. Okay, convenience and security positive 0.275. Okay, so indicate that there is a positive relationship, okay, between convenience and security. Okay, but the points are scattered with quite a big variability. Okay, and then the coefficient of correlation expected to be low or moderate. Okay, and then when we compute based on the output of the correlation coefficient just now, okay, kalau kita tengok pun actually dia punya correlation pun very low lah. Okay, the convenience and security, convenience and security, sorry, based on this one, convenience and security, which one? Okay, so the relationship is 0.345, so which is less than 0.4 is considered as a low relationship. Okay, and then after that, okay, if you want to determine, okay, the significant factors that cause change in the variable of interest, okay, you can run regression analysis. Okay, so for example, determine factors that influence permanent stress among teachers. Okay, so we can use the regression analysis. So in regression analysis, we have independent and the dependent variables. If we only have one independent variable, so we call it as a simple regression model. Okay, but if we have more than one independent variable, so we can run a multiple linear regression analysis. Okay, so there are several types of regression model. Okay, the common one is the multiple linear regression. Okay, logistic regression if the dependent variable is in a binary, maksudnya kita ada yes, no, male, female, agree or disagree, so that is under logistic regression. Okay, discriminant ordinal regression. Okay, ordinal if the category is in a ordinal. Okay, multinomial regression, okay, if the dependent variable are in a nominal form. Okay, so there are several types of regression model, but for demonstration I will only highlight on the multiple linear regression. Okay, so this is the general equation for the regression model. So we have the dependent variable and the list of set of independent variables. Okay, beta null is the intercept. Okay, E actually is the error term. Okay, to run the multiple linear regression. Okay, so this assumption need to be satisfied first. Okay, the error term are independent, identically normally distributed with zero mean and constant variance. There is linear relationship between dependent and the set of dependent variable, and there is supposed to be no multicollinearity between the independent variable. Okay, so we will check all these assumptions whether they are satisfied or not. Okay, so these are the steps on how to run the multiple linear regression. Okay, first, okay, we check the correlation matrix, okay, to see whether there is a multicollinearity or not, okay, between the independent variable. Okay, the problem, if there is a multicollinearity, the model will be overestimate. Okay, the value of r squared will be high, but the independent variable, there is a possibility that they are not significant. Okay, so we try to avoid to have the multicollinearity problem in the model. Okay, and then we estimate the regression model. Okay, do the diagnostic checking. We check whether the error terms meet the assumptions or not. And then do the interpretation. Okay.